In this question, you need to identify most stable carbocation. That is, here say first option CH, this is cation CH2 plus is there. Opposite to this, nothing but at para place OMe is there. So somewhat your answer is this. But here if you check this one, there here it is more, I mean it is going to be destabilized more, because this is attached to the benzene ring. Here also, when this is also electron donating group and this is also electron donating, this is also electron donating group, but the electron donating group is present at para position to the carbocation, then that would be the stable. So that is the reason this one is your answer. In this question, we need to identify correct stability order for the following carbocations. See, listen, one thing you need to remember, the carbocation would be stabilized by electron donating groups or plus M groups. Here, see this one, oxygen is there here and here also oxygen. So, here actually first one is most stable carbocation, because see here, this is oxygen electron donating and also this is carbocation. See, two carbon atoms are going to attach to this center. So that means this is secondary carbocation. So that first one is most stable. After that, from these three, third one will comes. Because here also oxygen attached to the carbocation. And then after, from second and fourth, the second one will comes here, because the reason this side CH3 group is there, this side and alkyl group is there. That is the reason from both sides electron donors are there. But if you consider this one, only one side electron donors are there. That is the reason 2 comes first and then after 4. Dear students, in this question we need to identify correct stability order for all these 3 molecules. To identify stability order, you need to follow, you need to identify Huckel's rule, which molecule is going to be follow Huckel's rule, that is comes first, more stable. Okay, so here if you observe this one, here 6 pi electrons are there, here 8 pi electrons, here 4 pi electrons. So if 6 pi electrons are there, that is the aromatic compound as per Huckel's rule. Okay, 2 pi electrons, 6 pi electrons, and then 10 pi electrons, 14 pi electrons, these are all comes under as a Huckel's rule, 4 n plus 2 pi electrons rule. Okay, so Q comes first. Q is more stable than P and R. If you consider P and R, see, P has 4 electrons, R has 8 electrons. Not only 8 electrons, this one is cycloocta tetraene. This is having tub shape, that means a little bit more stable when compared to this one. That is the reason this one comes first, later on P. If you observe here, this is aromatic compound, this is non-aromatic compound, and this is the anti-aromatic compound based on Huckel's rule. In general, this one comes under as a anti-aromatic, but because of lack of, that means formation of tub shape, this one comes here. Okay, non-aromatic. See, in this question also you need to identify most stable carbocation. Here if you check first, third and second one, from all these 3 options, oxygen is there. Oxygen, that means here it is having electron donating group. But if you consider first and third options, in the first option electron withdrawing group is there, C double bond O group. So this is not comes first. This one comes first, because see, continuous conjugation plus next double bond, next electron donor. So first stable one is the, third one is the first stable, and after that Second stable one is the second option. Next one is the second option. Here see, double bond is there, and then here. This is the second. Next one is first option. First molecule will comes here. See this one. After that, fourth one. In this question also you need to identify most stable carbocation and also correct order you need to identify. See this one here, C comes first. C is the most stable. How many carbons are here? 1, 2, 3, 4, 5, 6, 7. See, triene, this one is a triene and also aromatic. After that, see, triphenyl carbocation, triphenyl, that means A. And after that, this one, B, diphenyl carbocation, and then after D. So this is also one of the most important question. In this question, we need to identify steam volatile compound. Among these four options, if you check here, see, A and B, these two are the ortho-substituted compounds. C and D, these two are the para-substituted compounds. So that here, if ortho-substitution is there, that means see here OH and NO2 is there, NH2 and NO2. That means hydrogen in conjugation with oxygen are more electronegative atoms. So then there is a intramolecular hydrogen bonding formation is there. So that A and B, these two are your answers. That means you will also have remaining options A, B, C, D. So among those four options, A and B, that means that is one option. That is your answer. Here in this question, we need to identify IUPAC names for these compounds. You will have options in down in your examination. I didn't write those options here. Just try to understand, okay? See, if you give numbering to this one, 1, 2, 3, 4, 5, here 2 carbons, 6, 7, okay? 6, 7. So, here this is what? 3 ethyl. At third place, ethyl group is there. At fifth place, methyl group is there. So, is there any option like that? 3 ethyl, 5 methyl heptane, 7 carbons means heptane. So, here this one. 3 ethyl, 5 methyl heptane. A becomes 2. A becomes 2. Okay. Next, here if you observe this one, see, CH3 twice, C3H7 twice. If you write this one like this, this is CH3, this is CH3, CH2, CH2, CH3, another one here I am writing CH2, CH2, CH3. You should write like this. Then you can easily identify. See, 1, 2, 3, 4, 5, 6, 7 carbons are there. In the straight chain, 7 carbons are there. At fourth place, 2 substituents are there. These 2 are the substituents. That means 4, 4 dimethyl heptane. This one is 4, 4 dimethyl heptane. That means B is 3. B is 3. Okay, na? Next, C option. Next one. If you identify this one, 1, 2, 3, 4, 5. 5 carbons are in the straight chain and 1 substituent is there. That means 2 methyl 1, 3 pentadiene is there. 2 methyl 1, 3 pentadiene. See this one. C is 4. C is 4. Next, D is what? Once you D is first, automatically first one. Okay, that means if you give numbering 1, 2, 3, 4, 5, 4 methyl pent-1ene. Okay, 4 methyl. Here see, 4 methyl pent-1ene. This is also one of the most important question in the estimation of sulfur. See, 0.20 grams of pure organic compound gave 0.40 grams of BaSO4. That means here organic compounds weight is 0.40 grams, and BaSO4 weight is, sorry, organic compound weight is 0.20 grams, BaSO4 weight is 0.40 grams. So to this you can write, by using this formula, that means percentage of sulfur equal to sulfur atomic weight is 32 upon molecular mass of BaSO4 233 into weight of BaSO4, given weight 0.20 grams upon organic compounds weight 0.40 into 100. If you simplify this one, you will get 27.5%, but here you need to write in the form of integer value. So here it is, if you multiply with 10 and divide with 10, then it will become 275 into 10 power minus 1. So this is your answer. Here in this question you need to identify how many different stereoisomers are possible. See, this one is one chiral center, and you can consider double bond also one chiral center. So then you can use 2 power n formula. That means 2, n value is here 2, so that here it is having 4 different stereoisomers are there for this molecule. See, here in this question we need to identify how many different stereoisomers are possible, just like previous one, but here only double bonds are there. So 3 double bonds are present. So the n value here you can take 2 power n equal to 2 power 3. That means 8 different stereoisomers are possible for this molecule. In the next question, IUPAC name for this molecule. See, here you can give numbering from here. 1, 2, 3, 4, 5, 6. Okay na? So you can write here at 6th place methoxy group is there. So you can write like this: 6 methoxy carbonyl, 6 methoxy carbonyl, 2, 5, see this one and this one, dimethyl, 2, 5 dimethyl. How many carbons are there? Meth, eth, pro, but, pent, hex. Hexanoic acid. This is COH group. Hexanoic acid. The IUPAC name for this molecule is 6-methoxycarbonyl 2,5-dimethyl hexanoic acid. These are I have taken from these questions from all questions from previous year paper. So just listen and try to apply all these models in your examination.